Okay, hello, I am Jordan Atkinson, and this is my critical reflection of using PRIMM to teach programming. So, what is PRIMM? PRIMM is a lesson structure that is specifically tailored to teaching programming. It breaks a lesson up into 5 stages: predict, run, investigate, modify, and make. The first stage of the lesson is predict. In this stage, students are given a section of code and instructed to discuss in pairs what the outcome of the program will be. The aim of this task is to familiarise children with coding language before they actually start coding. The second stage is run. The program is run to see how it behaves and to observe the outcome. It's important at this point to give students a chance to discuss if they were correct or not, and to explore why they might have been wrong in their predictions. Next is investigate. At this stage, students will explore the code using activities provided by the teacher. This can include activities such as tracing, explaining, annotating, and debugging. So, you could ask the children to go through the program and write comments next to the code, which is a good habit to get into for the future. Then we go on to modify, where the students will be asked to make small changes to the code that will alter its functionality in some way or another without changing any major concepts. And then finally, we move on to the make stage, which is where students are asked to make their own program using concepts explored so far in the lesson. Okay, so now that we know what PRIMM is, how could it be used? As I previously mentioned, PRIMM is a lesson structure that is tailored to programming lessons. So with this in mind, it only makes sense that we would use it in a programming lesson, like the one I have briefly created here. I have based this lesson on a series of tasks that we were asked to complete as part of the SKE, as I think they fit this structure well. So to start, I would show the students a program that could be used to calculate the area of a rectangle. I would group the students into pairs and ask them to discuss what they think the program will do. Then, after a few minutes, I would run the program in front of the whole class. It would be a whole class activity using a set of numbers I had predetermined. This would allow the students to observe how the program works and what the actual outcome is. And then, as I mentioned previously, I would give the students a few minutes to discuss if they got it right, and if they didn't get it right, why not. Then I'd move on to the investigate section, and I would ask students to go through the program and write comments that they think will help them remember how the program works in the future. This way, if they came to look back at the program in a few weeks, in theory, they should have a better understanding and be able to recall what the program does more effectively. After that, we would look at modifying the code. I would explain to the students what the formula is to calculate the area of a circle and how this relates to calculating the area of a rectangle. And then I would challenge them to modify the current code they have so that it could do this. Finally, I would ask the students to create me a program that could calculate how much AstroTurf I would need for my garden based on the size of the rectangle of the garden and the size of a circle flower bed in the centre of the garden. The students would use this information to calculate the area of a rectangle, then calculate the area of the circle flower bed in the middle, and subtract one from the other. This would tell them how much AstroTurf they would need to cover the garden. So, now that we've explored how the PRIMM method could be used to structure a lesson and what that might look like, we're going to talk a little bit about the advantages and the disadvantages and some of the current debate about this method. Okay, so now that we've talked about how we could use the PRIMM methodology, we're going to look at some of the literature surrounding the topic. So, one of the uh, topics that's talked about with regards to the PRIMM approach is that it applies a structure to programming lessons, making the material more accessible to students. The structure used closely mimics and is very similar to the use, modify, create method, which, according to the quote found on screen, supports and deepens the youth's understanding of computational thinking concepts. So you'll see this progression called use, modify, create describes a pattern of engagement that was seen to support and deepen youth's acquisition of CT, which in this instance is computational thinking in the author's projects. So, essentially, what this is it's a method of scaffolding learning that allows students to engage with the subject material, in this case, a program, by building from low level up to a much more cognitively challenging level. So, the learner will start with a program that they have absolutely no ownership over, and considering it's not their program and there's no ownership of it, the stakes are going to be a lot lower for the learner, because essentially what they're being given is a teacher's program, a program that's been made by the teacher prior to the lesson, and this is going to be a lot less stressful for them because they aren't thinking, okay, this is mine and it needs to be right, because they're working with something that's being provided to them by the teacher. So the stakes are lower and that stress is being taken off of them. They then move on to the second stage, which is this modifying the program stage. And it's no longer not the student's program. There is now a sort of joint ownership, which gives the students a chance to expand their knowledge and build on their skills, whilst only slightly increasing the responsibility and the stakes. So now they've got a program and it's like, yeah, this is still mostly the teacher's program, but the student has started to have some input on that, and so some of the work is theirs, and so they're going to start getting these small successes that are going to motivate them and encourage them without having that big stress of I've got to do this all on my own. And then finally they onto the create stage, which is where they create something of their own. The student gets a chance here to really engage with the task and develop some ownership of their learning. So at this point, this is the section where students will be challenged the most, because at this point in their learning, they are creating something based on what they've learned. And by scaffolding activities like this, the students will be constantly developing their skills without being aware of how far they've come. So they'll be taking a step-by-step approach, so that by the end of the lesson, when they've created something of their own making, they'll look back and see how far they've come without even realizing it, because there's not that instant stress of, okay, here's what you're going to be doing. It's a scaffolded approach. They start slow and they build up. Okay, so another area that's talked about is this concept of learning to read before you write. So this is another point that's considered, and this approach, this PRIMM approach, places an emphasis on teaching how to read programs before you write them. Now, personally, I think it's really important, because reading programs, I know in the past, has helped me to develop my logical reasoning skills. So when you learn to read a program, you see how the logic behind the solution works, and it develops that logical reasoning and problem solving, or at least for me personally. And the article I read backs this up, and it emphasizes this idea that it is beneficial to the learner to learn how to read programs before writing them. So the article I read was by Sue Sentence, called Teaching Computer Programming with PRIMM, a Sociocultural Perspective. And it talks about novices writing programs before they are able to read them being a known issue. And it talks about the fact that this is a prominent issue in computing, and it's something that needs addressing. And I completely agree with this. When I think back to my early days programming in college, I think the very first thing we did was load up Python and program Hello World. It was one of the very first activities we ever did. We were never taught to read the programs as much as we were, let's just get some programming practice in there. So this article goes on to say that PRIMM focuses on students talking. So if you'll look at the quote I have on screen, it focuses on students talking about how and why programs work before they tackle editing and writing their own programs. So there's quite a large focus on students talking and conversing. In fact, the whole article is very in favour of social constructivism and discusses the works of Vygotsky and the like. The author then goes on to say that they have conducted some kind of research that has yielded positive quantitative results of learner outcomes, which are supported by this anecdotal evidence of how the teachers explain why this method works for them. I think it's worth mentioning that the writer of this article is the creator of the PRIMM approach, and with that in mind, there is obviously a very sort of blatant motive for bias within the article that needs to be considered. Obviously, this is literature around her approach, and so there is the chance that her opinion might be biased on the matter. And then they discuss this idea of social learning. So this is another area that's talked about regarding the PRIMM approach. And as I've previously mentioned, this methodology is rooted in a social learning style, in that a large focus is placed on students discussing and conversing with each other. So the first stage is all about students discussing their predictions with one another, and then in the second stage, after the code's been ran, they go back to discussing about were they correct, were they wrong, why. So there's a big focus on social learning. You'll see the quote I have on screen, the first quote: many PRIMM activities are carried out in pairs, and we already know that pair programming is an effective form of learning. So pair programming is a separate pedagogical approach to teaching that involves pupils working together to create programs using driver and navigator roles. So essentially the driver will be put in front of the keyboard or the pen, depending on the activity, and their job is writing down what the navigator says in correct syntax. So they split the cognitive load between the two of them. One is responsible for writing the code while the other comes up for the logic for the solution. So they go on to say that several benefits of pair programming have been observed in a range of studies. Through pair programming, the individual cognitive load of both learners is reduced, as I just said, because the tasks to complete are shared between them. Another article I read goes on to say that studies of pair programming in introductory programming courses offer compelling evidence that it can help to reduce high failure rates. So this is an area that has been talked about, as you can see, in multiple literature sources, and it goes to suggest that this PRIMM approach and having these social learning styles really does help to develop the student's ability to access the material. And then another author goes on to say that talking about a program and how it works helps learners to find the right terminology to use to articulate their understanding. So going back to my explanation previously of this driver and navigator role, placing the navigator in a position where they can't do any of the programming or any of the write-up really puts them in a position where they have to find the right terminology to explain what it is they're thinking and their ideas. And this same logic applies to the PRIMM approach. In the first few sections where they're discussing what they predict will happen and why they think they were either right or wrong, it gets them into the routine of using correct terminology to explain themselves. So things like talking about, that variable stores this information, which is then going to go on to have such an effect. And yes, so this has been my reflection and my exploration of using PRIMM as a methodology for teaching programming. And just a few concluding remarks. I think the literature speaks very highly of this approach, and I have found in my personal experience teaching that having a structure to lessons is very beneficial, and I would much like to explore PRIMM further. Thank you for listening.